Hi everyone, I'm Micaiah D, and this is my lab report, Charge Tape, for Physics 2212. A little background on this lab. We were expected to create a net charge on pieces of Scotch tape and measure the excess charge on one piece of tape by observing different interactions. The goal of this lab consisted of gaining a better understanding of the electric force, also known as Coulomb's law, between everyday objects and how electric fields affect matter, as well as visualizing the concept of the transfer of charge. Some physics principles to keep in mind are: an object cannot exert a force on itself. Like charges repel and opposites attract. Results: I identified the sign of the charge of the Scotch tape to be positive. When I calculated the charge, I got 1.374 e to the negative 8 coulombs, which was within the same magnitude as the textbook example. And I created a virtual representation of the experiment in Python by adding functions to calculate charge and using old functions from previous labs to help find the forces. Data: I measured the initial height of tape B before I introduced tape A. When I introduced tape A, the distance between tapes increased. I observed that the charged tape was attracted to the negatively charged pin, which meant that the sign of the charged tape was positive. The net force on tape B is 0 since the tape didn't actually float. The center of mass moved slightly, and this movement was due to the repulsion between the pieces of tape, which caused B to float. Calculations: notice how the gravitational force and electric force are equal in magnitude but opposite in direction, which makes sense since the net force on tape B is 0. I use this knowledge in helping calculate the charge Q. I isolated Q and I used the measurements to help find the result. When I did this, I ignored air resistance and treated the tape as a point particle. Ratios: the number of electrons on tape B is the resultant charge divided by the electron charge. The number of atoms on the sticky side of the tape is the tape length divided by the atom's diameter, which was provided for us. The ratio of electrons to atoms is the number of electrons divided by the number of atoms. Coding: you can click this link and it will take you to my computational model. Here you can see that the answers that I said previously are the same for the calculations. Here is tape B. The orange arrow is the electric force. The green arrow is the gravitational force. They are equal in magnitude but opposite in direction. Tape A, you can notice that it only has one arrow, which is really two arrows, since the electric force and gravitational force are in the same direction and are equal in magnitude. You can click this and you can see how I got my computational model. So some final questions. What if electrons had a positive charge and protons had negative charge? Well, the sign of the tape would change for my experiment, but everything else would be relatively the same. Charged objects still attract neutral objects, the U-tapes would still repel each other, so the laws of physics are not broken. Why is it important to handle the charged tapes as little as possible? I personally faced this problem when I kept having to recharge tapes, since the transfer of charges through contact caused the tape to lose charge, and interactions didn't happen as expected. U-tapes would no longer repel each other, and the U-tape would not be attracting to my hand or other objects such as books. In conclusion, the lab helped demonstrate the transfer of charge between everyday objects, as well as visualizing Coulomb's law and Newton's third law, the reciprocity of forces, which I showed you with my computational model. I was successful in calculating excess charges. Thank you so much for watching, and I'll come back with more physics fun.